So welcome to Module 6. In Module 6, we're going to talk about probability. Okay, so the probability is part of statistics, and it is an important one in the sense that whenever we talk about how this probability can occur, for instance, there is an 80% chance of rain tomorrow kind of a thing. So when a weatherman tells us there is an 80% chance of rain tomorrow, that we are actually talking about a probability of that particular event, the rain, which is going to happen tomorrow. And probability is it's a likelihood of a particular event. Okay. And this likelihood of a particular event is an important thing in statistics. So before we go further, one of the things that we want to talk about is what are the different things, or what are the different terminologies that we're going to be using in probability. The first one is experiment. Experiment, for example, if you roll a pair of dice, that is an experiment. Basically, what we are saying is this is the process of measuring or observing an event. So when you roll a dice, it gives you the ability to measure or observe the event which is going to happen after you roll the dice. An outcome is the result of an experiment. So if you roll the dice and you get a pair of threes, then that is the outcome. The pair of threes, which is actually equal to 6, is the outcome. One of the important things that you need to look at is the sample space. The sample space is all the possible outcomes of an experiment. So if you're throwing 2 dice, the sample space will include 1 plus 1, which is 2, 1 plus 2, which is 3, 1 plus 4, which is 5, and so on and so forth till you get 6 plus 6. So because you have 6 faces, and 1 is the least number and the 6 is the highest number, right? So you can see that 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12 will be the sample space. So the total sample space is going to be all those events. Like, for instance, it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that'll be your sample space. An event basically can be one outcome, or it can be multiple outcomes. We can say that you want 2 when rolling a pair of dice. Or you can say, I want either a 2 or a 3 or a 4 or a 5 also. So both of them are events. So one event will be rolling of 2, 3, 4, or 5. The other event is just rolling 2. But the sample space for both of them will be the same, right? Which is basically the 2 to 12. Now, there are 2 things that we need to know. One is a classical probability, and another one is a frequency probability. And the classical probability is basically that a total number of outcomes in which event A occurs over the total possible outcomes in the sample space. So classical probability requires you to know the number of outcomes that pertain to a particular event of interest. So if you're rolling 1 dice and we are saying you want 1, and you roll a dice and you get 1, the probability of getting that 1 when you're rolling a dice is 1 over what is the total number of outcomes? That is 6, right? So it is 1 over 6. Okay, 1 over 6. So let's look at this in a mathematical way. And the mathematical way would be that the probability of that event A occurring will be the total or the number of possible outcomes in which event A occurs over the total number of possible outcomes in the sample space. Let's say you're rolling a dice and the event that you want is either a 2 or a 3 or a 4 or a 5. Okay, you want one of these 4 to occur. So let's take the sample space. the sample space will be 1, 1, 2, 6, 6. So you have 36 different outcomes that can happen. And that will be your sample space. The sample space is going to be 36. So that is going to be 1, 1 is 1, 2, 2, 1 is the second sample space, 3, 1 is the third sample space, 6, 6 is the 36th sample space. So your total number of possible outcomes in the sample space is 36. The total number of possible outcomes is 10. How is that? We can count. So you want 2 or 3 or a 4 or a 5. So if we roll 1 and 1, that becomes 2. If we roll 2 and 1, that becomes 3. If you roll 3 and a 1, that becomes 4. If you roll 4 and a 1, that becomes 5. Similarly, 1 and 2 will become 3. And similarly, 1 and 4 will become 5. So basically, the outcomes are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of those red letters, the red combinations. So that's why your possible outcome is 10. So the probability of an event A, which is rolling a total of 2, 3, or 4, or 5 with 2 dices, that is the event. The possibility of that, or the probability of A, is going to be 10 over 36, which is 28. So 28% of the time when you're rolling a dice, it is going to be that you will get either a 2 or a 3 or a 4 or a 5. That's the whole idea of this probability. Okay, now I'm going to look at what is an empirical probability. An empirical probability is we do not know the process to determine the number of outcomes. Okay, so we don't know the number of outcomes. So for that, what we are going to do is to count the frequency. So the probability of event A in empirical probability is that frequency in which event A occurs over the total number of observations. Okay, so let's do the calculation based on this. Probability that event A will occur will be the frequency in which event A occurs over the total number of observations, right? That's what we talked about. How do we do that? So let's take a student, John. John needs wake-up calls. Okay, so somebody observed how many wake-up calls John needs to wake up over 20 school days. The first day he needed 2. The second day he needed 4 of them. The third day he needed 3 of them, and so on and so forth. They made how many wake-up calls? They calculated how many wake-up calls. They observed how many wake-up calls that John needs to wake up. Okay, and this is the data. Now, like we did before, we're going to convert this data to frequency distribution. You remember we did that before? We're going to do the same thing. How do we do that? So we're going to have 4 bins. And the 4 bins are, in the past what we did was a range. Here we are doing just the numbers. You can do either way. You can do it as a range, that is 0 to 1, 1 to 2, that kind of a thing, or 0 to 1, 2 to 3, that kind of a thing, or you can say 0 to 2, 3 to 4. You can make only 2 bins. So here I'm having the number of wake-up calls as a bin. So 1 is the number of wake-up calls equal to 1 is 1 bin. Number of wake-up calls equal to 2 is the second bin, and so on and so forth. Now I can say that number of wake-up calls where John needs equal to 1 is going to be 1 here, 1 here, and 1 here. So he did it 3 times. So 3 times out of these 20 days, on 3 days, all he needed was 1 wake-up call. Maybe he didn't party that much. That was the reason. Whereas on certain days, he needed 4 wake-up calls. For instance, the second day he needed 4 wake-up calls. You know, on this day he needed 4 wake-up calls. He was partying a lot on those days maybe. So when you say we can calculate the number of observations, and from there, like we did before, we can calculate the percentages. So we can say that for a probability of John waking up with just one wake-up call is only 15%. John waking up with 4 wake-up calls is 25%. Okay? Or John waking up with anything more than 2 wake-up calls, anything greater than 2 wake-up calls will be equal to 0.4 plus 0.25, which is 0.65 or 65%. So 65% of the time, there is a possibility that John will wake up after 2 wake-up calls. There is a probability of 85%, if I add this 20% to that, there's a probability of 85% that John would wake up after just 1 wake-up call. Okay, so you can find out the empirical probability in all these kind of things very easily. Okay. So one of the things that you can do in the empirical probability and the classical probability is this way. Let's say you're flipping a coin. Flipping a coin basically can occur with, let me get my red pen. So flipping a coin with can occur like you have heads and you have tails. So if I do 3 times and all of them are heads, the empirical probability will be equal to, for 3 heads, that will be equal to 3 out of 3, which is equal to 1, which is 100%. So 3 times it's going to happen. But the classical probability is going to be, it can happen like 1 by 2, because there are 2 faces to the coin. So that is 50%, right? So the way that empirical probability will be equal to classical probability, the classical probability equal to empirical probability, is that if I flip this coins many times, the classical probability will be sort of getting equal to empirical probability. Okay, that is when the classical probability can become equal to empirical probability. So you got to have a large sample size, or the entire population, for the empirical probability and the classical probability to be about the same. Okay, so that's pretty much is what we have in module 6.